though not all, and it is alongside other things that are important, like comfort and reducing energy bills. But the reason that we're bothered about carbon is because it has a real physical impact on the climate that we are all trying to live in. If you haven't got your warming stripes yet, there's the web link available there. It's quite a fun thing to do, but obviously the last few years especially, things have been getting really a lot warmer, and what we're trying to do is mitigate and reduce the amount of warming that we're going to end up with this century. And the main way that we're talking about doing it here is by reducing the carbon emissions from our homes. There are a lot of different terms that get bandied about. People talk about zero carbon, or even being carbon positive, which is quite ambitious. At the moment, we live in a world in which a lot of the systems that we have to deal with, the economic systems, the energy systems, the processes that go into making stuff, all carry some kind of a carbon cost. And it can be quite confusing sometimes how that gets accounted for and where you draw the boundaries, which is something that I think both John and Julianne and Lois are all going to talk about. We have always advocated a fabric first and a whole house approach, because we know it works in reducing carbon emissions, so that you're reducing the risk of performance gap by basically doing things that are sensible and simple, like improving air tightness and improving insulation, but also having lots of other benefits around it. But we've always had a bit of a debate about to what degree that needs to be done. So is it okay to just do a bit of loft top up and slightly better windows and air tightness? Do we need to go a lot further? We've generally aimed to go a fair bit further than that, but often not actually being able to go as far as some other groups and organisations have done, because we're working with often limited budgets, but also limited capacity for disruption, all of that kind of stuff. That means that we don't always all end up with something approaching passive house, though it might be a step along the way there. When we did the Community Green Deal, which was back, the actual design work for it, a lot of it was done in 2013, so this is quite a long time ago now. And we talked about the target, that being 17 kilograms of CO2 per metre square per year. And that came from something that was even a couple of years before that, the Retrofit for the Future programme, because at the time that was what people were saying that we needed to get to achieve that 2050 decarbonisation. That is kind of tricky, and what we've realised is that counting and targeting carbon in our homes is quite difficult, because we're living in a changing energy system, and what something that John will talk about in a bit more detail in a moment. We've always looked at space heating demand, because that, for most houses, that's the biggest use of energy. And it's also the thing that has an impact on those other things like comfort and health. We're interested in where that should end up and where we need to be to achieve that actual real life zero carbon outcomes, because we talk about it in things like My Home Energy Planner, and when we're doing our strategizing for where we need to get to.
Marianne, do you just want to unpack the concept of space heating demand a little bit? Because it's a term used quite a lot, isn't it?
Yeah, so, and this is why it's really important, isn't it, to be really clear about what you mean by certain things. So the space heating demand is basically the amount of energy that is required to top up your home to keep it to a reasonable degree of warmth and comfort, once you've accounted for the losses and the gains. So it's kind of losses through the fabric, through ventilation, and through kind of drafts and leaks that are also topped up. So things that you do in your house, like cooking and bits of solar gain, they also top up some of the heat in your home. But the balance between those two is what you then have to get a heating system to kind of pump into your house to make it comfortable. So when we talk about space heating demand, that's what we're referring to. And it is independent of whatever heating system you've got. It's just about the physical properties of the kind of fabric of your home. And the other thing that we're really aware of is that you could do a lot of work to retrofit your home, but in doing that work, there is also an energy and a carbon penalty. So we want to make sure that when we do that work, we do it well, do it properly, do it to the level that it's required so that it's not wasted. Lois is going to talk a bit more about that side of things and where the balance might sit. And it can get a little bit complicated. And I think especially over the last few years, because Carbon Co-op have developed their energy services team as well, we have always been in mind, because Carbon Co-op has always been a kind of cooperative effort. It's about a group of people doing stuff, that you're not just an individual doing things just to your home, it's part of a wider effort. But that also your home is part of a wider energy system as well, and it's how what you do in your home, and if lots of other people did the same things in their home or didn't, how that impacts on that wider energy system. And that energy system itself is changing really rapidly. So we've got a massively rapidly decarbonising grid, which a few of us, when I started out in this, the no-brainer thing to do was put in a really efficient gas boiler and put PVs on the roof, because the amount of carbon emitted for every kilowatt hour of grid electricity was about, well, at least twice what it is now. And that has changed, especially over the last couple of years. So that changing context changes maybe what we should think about doing. So this is kind of how we're trying to think of things, in that we know we need to have housing that has a lower energy demand, and we know that the energy system more widely is hopefully decarbonising even more rapidly over the next decade or so, but eventually hopefully will be zero carbon. You're not actually going to get zero carbon homes until those two things kind of come together, and we need to think of the two things in tandem as well. So it's what you're doing in your home that has system effects, and then from those system effects what the target should be for your home. And it gets quite messy. So that's why we're talking about, because at the moment we don't live in a set of systems that are zero carbon, and the only way that you can potentially get to something like net zero at the moment is probably by offsetting in some way, which there's lots of interesting accountancy that can be done around that. But that's why we're talking about maybe what is zero carbon ready. So what can you do now in anticipation of wider things around you changing, and what might that mean? And I think the next three presentations are going to go into kind of some of the issues around that in a bit more detail. So that's it from me.
Thanks, Marianne. That's really good, and it's a really good way to set up the debate and the discussion there. And because the house is a point of nexus where you have all these different things coming in from different areas, the decarbonisation of the grid, but also the demand on individual houses and reducing as much as possible. We're going to hear from Julie now, Julie Godfrey, who works at CIBSE and is also an environmental consultant, independent. And so Julie, John and Lois will pick up different elements of what Marianne's introduced and unpacked. Julie's going to be talking in particular about why heat matters and stuff around fabric performance. Julie, are you able to share your screen?
I can do now.
Fantastic. Great to see so many people here, by the way. Between the screen sharing, you can see everyone's faces, and it's fantastic to see so many people.
And so you should see my screen now. Is that
yeah,
right?
I can see it. Yeah. You might want to go full screen. Yeah, there we go. That's perfect.
Hi, everyone. So I'm a sustainability consultant and engineer by background, and I'm talking tonight as me. So if there's anything you don't agree with, blame me and not CIBSE. And I'll talk about, yes, why retrofit matters and why doing it properly matters, in particular for heat, and why in order to do that, we can't really rely on current regulations. And John after me will then tell you what you can do in addition to following regulations. So as Marianne said, a big driver at the national level as well as the householder level is carbon, really. And that's in large part because we expect the electricity grid to decarbonize significantly in the next 10, 20, 30 years, even more than it already has. However, at the moment for gas, I mean, there's a potential hypothetically about hydrogen, but we really don't know when that would happen, if that would happen, how much that would cost, etc. So without this, really, the proportion of emissions that we would still have to reduce in order to meet net zero carbon in the UK is quite significant. And that's the example from a local authority I've worked on. So looking at all their buildings, so council-owned buildings, council homes, leisure centres and schools, if we did nothing, took the same stock, we would actually achieve quite a big savings through electricity decarbonisation alone, but we would still end up overall with a massive amount of carbon emissions because the gas grid would just be as it is. So first of all, we really need to address heat, and that's particularly true for homes. The second reason is that, again, at the system level, we have much more peak capacity available in the gas grid than we do in the electricity grid. Now that graph is often used and it's to some extent debated, but it's a good illustration of the fact that gas consumption varies hugely. It's much higher in winter than it is in summer, and the gas grid has been designed to cope with this, while the electricity grid, the demand is much more stable throughout the year and it is lower. So if we just switch from gas to electricity without reducing our demand, we would have problems at the national and or local level in meeting the actual demand. So it's not only about how much we consume during the year, but it's what we need in that one cold winter day. At the building level, for us as homeowners, it's also pretty important because, again, we could have a boiler or another piece of kit that meets our demand most of the time, but actually the size we would need to keep us warm on that cold day is much higher. And a boiler doesn't take that much more space and is not that much more expensive to do much more for us. While when we start looking at alternative technologies like heat pumps, etc., they may take much more space and or cost much more when we buy them. So it is really important to try to reduce this massive demand for a few days in the year, as much as how much we consume throughout. A question we often get asked is, well, with climate change, will heating still matter? The answer is yes. So currently, deaths from heat waves make the headlines, but they are actually much lower, even in a bad heat wave, than excess winter deaths. Now, excess winter deaths also include deaths from flu. So it's difficult to precisely allocate what is due to cold, but it's usually estimated at around 10 or 11,000 a year in England and Wales, which is way higher than even in the worst heat wave we've had in England. The other thing that's happening is that we're becoming better at managing heat waves. So we have warning systems in place, we make sure people are not alone, have had water, etc. While people in fuel poverty in cold homes really have an issue. And even accounting for climate change, UCL and the Committee on Climate Change estimate that even in the 2080s, yes, there will be fewer deaths related to cold, but they would still dwarf those related to heat. So heating will still matter in the UK. The other thing we often hear is, well, can retrofit deliver? There's loads of horror stories about what can go wrong. For example, mold, ventilation, poor ventilation, condensation related to thermal bridging, overheating, deterioration of insulation, and also what is called the rebound effect. So you don't actually get energy savings because people put more heating on. Yes, that can happen. But that's why it's important to do retrofit properly. As Marianne said, adopting a whole house approach and sharing as we learn all these lessons about that type of insulation or that setup being dangerous, etc. The other thing is that I think when you look in detail at the studies with the so-called rebound effect, yeah, maybe people are putting more heating on and they're more comfortable, but a lot of the time it's a good thing. It's not that they suddenly swan around in t-shirts in an overheated home, is that previously they were underheating their home and actually pretty uncomfortable, potentially with health effects. It's not the case in all studies, but it does happen quite a lot. So it's a bit unfair to say that people are just overly comfortable now. There's guidance emerging, for example, the PASS framework on how to do things properly, in particular following that whole house approach Marianne mentioned. And what that means is that we can't just look at heat on its own. So if we install insulation or if we improve how much air leakage there is through the fabric, we need to think about what other consequences that might have, not only on therefore the impact on energy bills, but maybe on overheating, on whether we need ventilation, etc. And what it also means is that it's useful to have a plan about where you want to go in the long term. So you probably want to achieve zero carbon or huge carbon reductions in the first step, but if you have a plan for what you can do when you have the money, when you have the time, when it's less disruptive to you to do more works, then you're making sure that you're not doing something now that prevents you from doing something else next time, because sometimes you might do a little bit and realize that has blocked another measure you could have done in the future. So all these good practice standards help you set this out. The other things that, again, Marianne mentioned is that doing things properly in a retrofit can have loads more benefits than just reducing your energy bill. So the image on the left-hand side is my house, and it's Victorian end terrace, very inefficient. And the picture on the very left-hand side is before I installed secondary glazing. It was taken winter nights at very similar temperatures. And as you can see, there's been quite a big effect in my windows. So I have to say it has improved thermal comfort a bit. I'm not sure it's done a lot to my energy bills, but it's made a lot of difference to noise levels. And that was actually my trigger. The windows are amazing. I'm very glad they've saved carbon, but the trigger, the day when I decided I was going to call someone to sort it out, was noise. It also shows that I still need to change my door, and that's in the works. Again, that's a nice illustration of how, if you have very good windows, you're generally just comfortable. It's not only about your energy bills, but surfaces are not cold, which improves your comfort overall. And the other benefit of doing things properly is that generally when you adopt really ambitious approaches and you work with people who know they are doing, general build quality improves. So it's not only that you save in energy and you improve the energy performance, but you also, many people report, overall get a better quality of the works. I mean, that's particularly true when you look at airtightness and people who look very much at the detail of how things have been installed on site. It's possible to do that well. There are some examples, and we're starting to see in the UK a range of approaches, from really bespoke adaptable approaches like Retrofit and pilot projects, through to methods that are much more replicable, that are meant to address, for example, rows of terraced houses. None of the approaches is very common yet, but we are starting to see a bit of a range of options available, even if they're not applied a lot at the moment. Now, if you therefore want to embark on it, this is the less positive half of the presentation, but John will pick up on optimism after me. Unfortunately, we can't rely on regulations alone. So you can't go to an architect and a builder and say, could you please do an energy retrofit of my home, and building regulations in the UK must be great. Can you make sure we comply? Regulations are the bare minimum, and they tend to be defined by the lowest common denominator. And that they were last updated a while ago. So that lowest common denominator doesn't take account of the climate emergency. And I would say there are three weak areas, broadly speaking. One is that the targets and the requirements are not good enough and not onerous enough. The second is that meeting the regulations will not ensure that you follow the right process and that the works are done properly. And the third is that enforcement can be patchy. Very often on a small project, the local building control will care a lot about fire and structural safety, but they will not pay much attention to everything else, especially energy. And there is no requirement in regulation to check that actually the house does perform as it was supposed to, and that you have now, for example, 20% energy savings or 50% energy savings, whatever your target was. To go into a bit more detail about why the targets and requirements are not quite good enough. So broadly speaking, what the regulations require, if you put new elements, so say you build an extension and you have new walls, new windows, there's minimum insulation levels, for example, or minimum requirements for how good that window should be. And there's also, if you have existing elements, which, for example, a garage that is now becoming a habitable room for you, which you will heat. If it was really not insulated at all, you need to bring it up to some level. They're not too bad. It's not exemplar, the requirements, but they're not too bad. And sometimes it's actually the best you might be able to do in your home because you have all sorts of constraints like space. However, it's very elemental. And I think a big failure of the requirements is looking at the home as a system and looking at things like junction. So it mentions the fact that you should look at junctions, you should be careful about airtightness and thermal bridging where two elements meet each other, but it's very, very high level and typically it's not looked at. The third thing is that on larger projects, you're also supposed to look at other things you could do. So if you're doing big works, it's asked of you that you should look at what potentially out of a list, whether you could also improve other things. But in fact, there's loads of loopholes and ways not to do it. And also it's a shopping list approach. So you could have a list of measures that the regulations ask you to do, but it doesn't at all promote the fact that you should look at them together. So you could meet building regulations by saying, I've done this, I've done that. And by the way, no one said it means I really ought to look at my airtightness and ventilation at the same time. So it's almost completely counter to the whole house approach. Now we're going to take a little break, and there's a poll that should come up with two questions. The first question is, do you know the energy performance certificate, so EPC rating of your home?
People should be able to see that poll now, but I can't see anyone voting on it.
I can see loads.
Oh, good. Oh, but maybe because you're the presenter, yeah.
Yeah, okay, so 55 people have voted and it keeps coming up. 58.
Okay,
Yeah.
I'm gonna finish it now.
Oh, okay. All right, so just over half of you, 57%, know the EPC rating. And then the second question is, do you know what it relates to, that rating? So is it a measure of your home's energy consumption, carbon emissions, energy cost, something else, or you're not sure?
Let me know when to finish it.
Yeah, so it's still climbing up. Gonna just give a few seconds more. Okay, so we are at 80% of people have voted. So the majority of you, half of you, say it relates to energy consumption, then a third energy cost, and the third, the remaining are a bit split. Mm-hmm. So what's the answer? So actually, when we say EPC rating, the EPC has two ratings. It's got what is called on the left the energy efficiency rating, and on the right the environmental impact CO2 rating. And in common language, when we say EPC, the EPC rating, we're relating to the energy efficiency rating. So it's not talking about carbon, it's energy efficiency, except that it's not, because it actually relates to energy costs. And let me check the, 34% of you knew that. Very well-informed audience, but still slightly confusing. And overall, it means that we have EPC ratings, which relate to energy costs, not energy efficiency or carbon, and building regulations, which, as I whizzed through, are patchy, to say the least. Do they work? Slide's not working. Well, the evidence that we have, there's no huge scale analysis available yet, but CIBSI should have some in a couple of months based on 100,000 dwellings. But at the moment, what we have is a very useful study by Etude of, based on 400 dwellings, I think, which is in one local authority. They looked at the energy consumption of 400 dwellings, and they classified that according to the EPC rating. So each bar that you can see here is the energy consumption on one dwelling. And if you can't see a trend, that's normal, is because there isn't really. We can't really say that the buildings that have the best EPC rating consume less than the ones that have the worst. It seems there's a little bit of a trend on average between, say, D and B, but to be honest, the worst ones, which tend to be the older, are not that bad either. So it's just nowhere near enough the level of step change that we want to see when we change building regulations. And just to finish very quickly, is government about to sort it out through the new grants that were announced, if not through regulations? So they announced 2 billion last week, I think it was. Now, I don't want to sound like money grows on trees, etc., but these £2 billion are not new money. They're a third of what was announced in the manifesto. And actually, if you look at the average cost of a deep retrofit, if we were to spend these £2 billion, we would cover between 126 to, say, 420,000 homes. That's not even a quarter of the households in fuel poverty, let alone a big portion of the total building stock. We don't know much about how government intend to spend that, but what they're saying is up to £5,000 in vouchers to householders. We don't know the detail. I think there's a danger with vouchers because, again, it's not the whole house approach. You could just go, buy a bit of insulation, job done, and you don't realize it's created other issues. what I would advocate is that these vouchers should at least be used to create a low carbon retrofit plan for your home. And that's it. I'll let John follow up now with things you can actually do. Thank you.
Fantastic. Thank you, Julie. Yeah, very controversial, touching on EPCs and the fit for purpose. So yeah, John, if you could share your screen. And I think please do put stuff in the chat if you've got questions or comments. And it was funny you touched upon the grant scheme, Julie, because there was loads of discussion in the chat whilst you were talking, before you were talking about that. So you followed it nicely. And yeah, just before John starts, Anika and Liam are compiling all the questions, so we'll feed them back for the panel at the end, although we're going to be limited in time. So yeah, we'll try and get through a few. Okay, John, yeah, take it away.
Right, good evening, everybody. Hopefully you can see my screen. A few nods. Yeah, great. So thank you very much for the invitation to be with you this evening. I've got a few topics which I've been asked to talk about. They are, first of all, I'm going to start off with whether we should be talking about carbon or energy. Then a little discussion on what what net zero might look like, why we shouldn't be aiming for net zero buildings to get to net zero. I'll explain that when we get to that point. And then finally, a few sort of figures on the scale of the challenge. So let's start with the carbon and energy. And I think we're going to do another poll now.
Oh yes, sorry, yes. Carbon and energy, here we go.
So the question is, if it appears, yeah, so how many people think we should be setting our performance targets for our buildings in terms of carbon or energy?
Can you see the numbers going up, John?
Yeah, 64%. I'll let you know when we're up to 75%, 79%, 80%. Yeah, I think that'll do there, close there. So the results were 56% think we should set targets in terms of carbon and 35% in terms of energy, which is excellent because that's the wrong answer. So let me explain why I think it's the wrong answer. So let's look at this light bulb. Let's consider that this light bulb might be a 1 kilowatt light bulb. I know it's probably a lot less than that. Do we know how much carbon that light bulb is going to release into the atmosphere at some point during the day? Well, we probably do, because we can use these handy little apps that currently tell us what the carbon intensity is of the grid. So on the day that snapshot was taken, that light bulb on for 1 hour would have released 211 grams of CO2 into the atmosphere. Great, so carbon is the answer. But later on that day, when it wasn't as sunny, the grid intensity was a bit higher, so it was a different answer. And next year, or the year after, when the grid intensity has changed, it'll be a different answer again, and it'll be different at different times of the day. And whilst, as Marianne and Julie also said, the grid is decarbonising, we don't really know what's going to happen in the future. Are we going to open lots of new offshore wind in the North Sea, or will that be scuppered? Will we have tidal? We don't know, because the government at the moment seems to be putting a lot of, betting the farm really on hydrogen, to be perfectly honest. So the grid may not decarbonise at the rate we know. So, or we expect. So therefore, it's very difficult to tell. In contrast, so if we compare those two, so right now in 2020, and we know it's somewhere between 150 on a very good renewables day to 298 on a poor renewables or overnight, that amount of carbon. And the energy is 1 kilowatt hour. In 2050, then we've no idea, to be honest, at this point in time, how much carbon is going to be released as a result of that light bulb, but we know that it will still be 1 kilowatt hour. So therefore, it makes no sense to set performance targets for buildings which are going to be around for the next 30 years in terms of carbon, because we do not know what's going to happen. However, if you set performance targets in terms of energy, then if you build an efficient house now, it'll still be an efficient house in 2050. So that's why it's the answer, as far as I'm concerned, is definitely energy, not carbon. Not to say we don't keep an eye on carbon. Carbon is the end game, it's very important, but performance targets really should start with energy. So let's move on to what does net zero look like. So this is what we might find in a typical new build UK house. The majority there, 86 kilowatt hours per meter squared per year, is heating demand, then hot water, and then lighting. So if we offset all that with generation, so add that up, 112 kilowatt hours per meter squared per year, then that's net zero, isn't it? People agree that's net zero? Any nods, any shakes? No, people are non-committant. So actually, Julie was talking earlier about EPCs. If you did this, your EPC would indeed tell you that you are net zero, because the EPC only deals in regulated energy, and regulated energy is exactly that. It's heating, hot water, and lighting, and a bit of pumps and fans that support your heating system. And the reason that that's done that way is, to be perfectly honest, because the other bits are really difficult. They're quite difficult to predict, and so we don't regulate them. And they are appliance loads, so everything else. So that actually must now all be, if we're trying to get to net zero, we can't just ignore things that previously were a bit difficult. We actually need to be serious about this, which means we need to take into account unregulated energy. So is that net zero if we generate enough renewable energy to offset that? Any thoughts on that? People still hovering on the fence? So the answer is not quite, to be honest. And the reason is because in the future, are we burning stuff? No, we're not burning stuff. So first rule of net zero, stop burning stuff. In particular, stop burning stuff that comes out the ground. So in our future nirvana, which we're kind of moving towards, but we're not there yet, we will not be burning stuff to generate our energy, which means everything comes from renewable sources. But there is a problem with renewables, and the problem is that they don't arrive when we want them to arrive. So at half time on the World Cup final day, when everybody pops off to make a cup of tea, it's not convenient that the wind blows or the sun shines. And that gives us, therefore, a problem with storage. And the problem with storage is losses. So if we need 100 kilowatt hours to run a house, but we have some storage, then we actually need to generate 120 kilowatt hours or 130 kilowatt hours in order to actually power that house, because we lose some of our energy in storage. And the amount we lose in storage depends on the storage type, but critically also depends on the length that you put things in storage for. So if we are generating renewable energy in summer, but we need most of it for our heating in winter, then that will incur some significant losses. And that means that the actual equation for net zero is unregulated plus an allowance for storage losses, because that is the reality of what's going to happen. So that's my definition of net zero. I'm happy to debate that with people later on the panel. So my next topic is about why we shouldn't be aiming for net zero buildings. So we're going to have another poll, I think, at this point.
Yes. Just a sec. There we go.
So this is, do you think we should be mandating that all new buildings, except that existing buildings are a bit difficult, all new buildings should be zero carbon on site? So that building itself should be net zero. We're up to about 40, 50%. Yeah, 75%, so we can close it there.
Yeah.
So the winner is no, which is excellent. So 43% think that we shouldn't, and 23% say we should, and 34% say we don't know. So quite a few don't knows. So let me explain again why I think the answer here is no, which might be a bit surprising. So this chart shows the actual energy demand. So the colours we had before with the heating, the hot water, the lighting, unregulated and storage, they're the same colours, but we now put them into one bar. And I've put it into, rather than per metre squared, it's the actual energy demand for a 68 metre squared house or dwelling. And you can see that the one far left is a current building regs with an air source heat pump building. And then we've got a passive house with an air source heat pump building, sorry, an air source heat pump in the middle. And then on the far hand side, I've shown you the same size of bar that's going to need to offset. So just under 4,000 kilowatt hours per year is what we're going to need to generate to make that building a net zero building. Okay, is that a lot? Is that a lot of energy? Few shakes. It's a fair amount. How many solar panels do you think that we're going to need for that? 14 solar panels for a 68 meter squared house. How big is a 68 meter squared house? Not big, is it? It's probably a 2-bedroom flat. So let's look at that graphically. So it's fitting 14 solar panels on a 68 meter squared house really only works if it's single story. As soon as you become gets 2-story, or actually 3-story, which is probably what we'd like to do with this size of building, it becomes impossible. It's too difficult to fit that number of solar panels on. And actually, what should we be building? Let's look at these 2 buildings, and some of you will be familiar with this concept of form factor, but we've got 2 buildings here. One has got 93 meters squared of floor area. The other has got 93 meters squared of floor area, but the top one has got 4 times as much heat loss surface area than the one below. So before we even start thinking about U values or walls or insulation, the building at the top is less efficient, and we have to do 4 times as much work in order to get it to the same level of efficiency as the one at the bottom. And yes, I accept that other apartments in the bottom will have heat loss ceilings and floors, but overall, building that kind of efficient shape of building with multiple, making best use of our floor area is going to cost us less and be easier to get to a more efficient building. So if I go back to my previous slide, what we're trying to do here, if we mandate that every building is net zero, is we're trying to drive people down the route of building bungalows, which is not an efficient way of using our land or our materials for that matter. So that's not the right answer, but obviously net zero is the right answer. So actually what we should be doing is we should be looking at the system boundary for net zero, not put it around the house, not really put it around the development. We could put it around regions, towns, but actually we would need to be looking at the whole country and maybe even broader holistically. And we need to be saying how much renewable energy do we need to get to net zero? And the way to make that easy for ourselves is to build our buildings and retrofit our buildings to be as efficient as possible. So that's why if we mandate net zero individual buildings, we'll drive the wrong sort of behavior and we make life much, much more difficult for ourselves. So finally, I just want to talk a little bit about the scale of the challenge. Let's look at some different building standards. On the left-hand side here, we've got a current building regs standard building with a gas boiler. Then we've got a 20% improvement in building regs, which was one of the options in the recent Partile consultation, and an air source heat pump. So that takes us down a bit. Then we've got the zero carbon inverted commas London plan, the passive house low energy building, the future home standard, which is a bit of a guess, and then passive house classic. So you can see how all those different standards stack up. And on the left-hand side of the scale is energy use intensity, which is a term that's been used quite a lot now, which is actually the energy at the meter that's going into the building. It's everything that's taken by that building in order for it to function, which is why I've said that storage losses are not included, because they might actually happen in the grid. So, do we have an infinite amount of renewable energy? Do we have to do this really difficult kind of make houses more efficient, retrofit type of thing? Well, what we've done is looked at how much energy we would need for all our homes in the UK if they were passive house, if every home was passive house, and worked it out per meter squared, and it comes out at about 45. We've then looked at the future energy scenarios the National Grid came out with a couple of years ago. They haven't updated the figures since, but in 2018, the figures compared directly were 35 in 2030 and 44 in 2050. So what does that tell you? That's actually staggering. What that's saying is that if every home in the country was passive house, not just the new ones, but all our existing homes, if every single one was based on was passive house, on current projections, we would not have enough renewable energy by either 2030 or 2050 to get to net zero. And Ian's mentioned that his future energy scenarios are updated every year. They are, but interestingly, they have not included projections for renewable energy in the last 2 years, which is quite telling, I think, because if you look at the UK CCC, what they're predicting, or what they're saying is the demand is well over 600, as opposed to 600 terawatt hours as opposed to the 400, which was in the future energy scenarios. So what we're saying is that at the moment we haven't got nearly enough renewable energy to cope with making all our buildings net zero. And of course, that's if every building was passive house. That's not the case. The problem, as ever, and I think as most of you guys will be well aware, is retrofit. Because most of our buildings that will be around in 2050 are already here. And very sadly, the buildings which we are building right now in 2020 will all need to be retrofitted by 2050 because they're not efficient enough. So that's a massive problem. And it's huge. And it frustrates me that I don't think the government have quite grasped the scale of the problem. If you were running your retrofits sequentially, then we'd need to have done one retrofit every 35 seconds from the 1st of January 2020 to the 31st of December 2050. But that's a bit of a silly metric because we don't do retrofits one after the other, and we'd actually do them in parallel. So let's say that each retrofit takes 6 months. That means we'd have to be running 500,000 retrofits simultaneously between now and 2050. And let's say that they need 4 people for each retrofit that takes 6 months. That means we need 2 million people in the retrofit industry, and currently we've got 135,000. So the scale of the challenge is absolutely huge. And of course, as Julie mentioned, we've had some encouraging news recently with announcements of funding, but it's actually just a drop in the ocean. So there are various estimates on how much energy we would need, how much money we would need to combat climate change, various percentages of GDP. The figure from the UK CCC is around 45 billion a year. 45 billion a year looks like that, and the spending allocated, even if all that 5 billion, even if all of it was new money, that's how it looks in the context of what we need to address climate change. So great that we've started, but we need to do a lot more. So what would Greta say? I painted a bit of an intimidating picture, but I just wanted to finish on a bit more of a encouraging note. So I spent some time in the Navy, so I'm going back to my roots here. Does anybody know what this is, other than a ship? So this is a Type T destroyer, photograph taken in 1945. Can anybody have a guess, put it on chat or shout out, how long it took us to build one of these during the Second World War? 6 months, a year, 2 years, 3 months, 4 weeks, 8 months, 12 weeks, 8 months. So 8 months is the longest, 14 weeks, 4 weeks is the shortest, 45 seconds. Yeah, I think so. Not far away though, because actually on average, between 1939 and 1945, we churned out this type of vessel or its equivalent, a total of an average of 2 per week. Wow. Which meant we were building this in 3.5 days, which is an absolutely staggering feat. But of course, at that point, we were spending 50% of our GDP on defense. Currently, we're spending something very small on combating climate change and even less on our buildings. The estimate is 2%. If we could spend 2% of our GDP, that's around the 45 million, then we could get this done. So thank you very much. I'll now hand over to Lois, I think, and then look forward to questions at the end.
Fantastic, John. And that was a really eloquent way of describing the net zero problem, which has been very hard to tackle recently because it's a very compelling kind of narrative, but it's difficult to communicate the complexity of that to a domestic, to a lay audience, really. So that was really good. Lois, are you there? You able to share your screen?
I'm just getting the hang of Zoom presentation. Bear with me.
So Lois is a PhD student at Heriot Watt, and she's going to touch on embedded energy and the role that plays in retrofit. What I would say is we're running a little bit late, so I think we're going to go we're going to extend it by another 10 minutes, 15 minutes. But yeah, Lois, if you could stick to the time allocation, that would be great. If you can get your screen shared, brilliant, fantastic.
Have you got full screen?
Yes, looks great.
Okay, so hi everyone, thank you for having me this evening. I'm Lois Hurst. I'm a self-build retrofitter. This is my house a couple of years ago, in progress, still in progress. I'll add I'm not meeting that time target that John was just talking about. I'm a PhD student at Harriet University at the moment, and my background is in environmental science, and I live in Lancaster. So my topic today, has it moved? No, there we go. Okay, so I'm going to be talking a bit about life cycle energy and retrofit, which I've spotted has been popping up in the chat a little bit, a few people asking questions about it. So hopefully I've got some interesting stuff for you to chew on. Here we go. So we can think of retrofit as a bit like putting a jacket on your house. It does the two main jobs of insulating, and when we zip it up, there we go, we make it airtight, so this reduces the amount of energy needed for space heating. So this diagram is a little bit more on the technical side, and it shows the insulation and the airtight membrane and the triple glazing and all of those good things that we're probably quite familiar with. So we've already covered this today. The energy that we use for the space heating, we call it the operating energy. So that's the gas that we're burning in our boilers or the electricity that we draw from our plug sockets. But we also have to consider the materials that we use in the retrofit. So the jacket that we've put on our house costs us in energy and carbon terms for raw materials, for manufacturing, for transport, and for the installation. And so over the lifetime of the building, the operating energy and the embodied energy can be summed together to calculate what we call the life cycle energy. So in some cases, it's possible that the energy that we're actually spending on the retrofit could end up costing us more than the savings that we make in the operating energy. So whilst we might have the warmer homes, it could mean, or could it mean, that in energy terms it would be better to have not put that jacket on the house in the first place. And this is kind of where my research is focused. How thick should we make that jacket? So whilst we might expect a thick jacket to have a higher embodied energy than a thinner one, it would also save more in operating energy. But unfortunately, it's not quite as straightforward as that. And we've got lots of other factors to consider. We've touched on this again already: moisture and ventilation. That means we need more equipment, so we might be putting in an MVHR system, and that pushes the embodied energy even higher. And so it's actually a complex series of trade-offs and compromises. And what we're wondering is there a position where we can find an optimum point on that curve where we're actually reducing life cycle energy overall? And so at the moment, we don't actually know where this lies. And this is why it's important that we consider embodied energy in the design considerations of the retrofit. But we've also got some other things to think about in terms of how we deliver life cycle analysis. So this curve, you've just seen my interpretation of it previously. I've actually borrowed this from a paper, Copiello 2017, and it shows a qualitative scale of conventional buildings, low energy buildings, passive house, through to self-sufficient or zero carbon homes. And it indicates that this progression shows buildings using less operating energy, but conversely an increase in embodied energy with an upkick as we get to self-sufficient buildings. So I've drawn some little illustrations here because I like to do things illustratively. And what I'm going to highlight is that these first three homes actually have one thing in common. And they all have a centralized power supply. So this could be renewable or non-renewable. I've drawn a power station of the classic kind because I think it's a good representation of power supply. But when we're doing a life cycle analysis of any of these first three homes, we would not usually include the embodied energy of that power infrastructure. And yet, when we look to the zero carbon home, which has got its PVs on the roof and maybe a battery inside, we would include that distributed power equipment in our life cycle analysis. And so here we're comparing different system boundaries. And the question there is this actually fair? And there are a series of other questions when it comes to life cycle analysis that I would potentially draw attention to. So, for example, is it fair to offset the renewable energy from the operating energy figure? You might have heard of terms like cradle to gate or cradle to grave. So these terms refer to the spatial and temporal extent that we conduct the life cycle analysis at. So cradle to gate would be that we look at only the impacts up until when that building was occupied. But cradle to grave would look at the impact throughout its life cycle, including the demolition at the end, and perhaps then turning those materials into new building materials for their next lifetime. We might also want to look at the physical boundaries of the building. So in some cases, the analysis is being done on the building and the hard landscaping, perhaps the tarmac driveway we put down. Another analysis might look just at the thermal envelope. And should we include the embodied energy that was spent in that original building? So we might include the embodied energy of the bricks that were put into the Victorian building 150 years ago. Or do we just want to look at the embodied energy of the retrofit? And then again, what's the lifespan going to be? Are we in a position to give a realistic estimate of what the lifespan of our building is going to be after it's retrofitted? Is it going to be 30 years? Is it going to be 100 years? Who actually knows the answer? And so, I've drawn some more animations here. Here we go. Here's my embodied energy of the conventional and low energy passive buildings without the solar panels, embodied energy with the solar panels on there. So anyway, what we know from all of these questions is that life cycle analysis is incredibly complex. And if we've got different analysts choosing different answers to all of those questions that I've just asked, then we end up trying to compare apples and oranges. And so it means that the results of one analysis and another are not really comparable. And that might lead us to ask what's the value of conducting that life cycle analysis in the first place. Of course, if we had a standardized methodology, the data would be comparable, and we could exploit that data then as a tool to drive down life cycle energy. But at the moment, we're just not there, so we're in a bit of a pickle with that. So I'm just going to put this into context for you with a quick look at some data. So this graph shows literature data, which I have aggregated from a number of different papers. We've got operating energy along the axis at the bottom, and that's in reverse order. So it's comparable there to the graph that I was showing previously with conventional buildings on the left-hand side through to self-sufficient on the right. We've got energy use up the y-axis, and the coloured lines are here showing the embodied energy. And this is of new builds and of retrofits. So I've grouped these according to the life cycle methodology that they utilised. And I'll also clarify that the data here is on a per annum basis. So the embodied energy was calculated over the life cycle and then divided by the lifespan that was allocated in that particular study. But interestingly from this, I think it was quite surprising for me to realise that these lines are actually nearly horizontal. And we're not actually seeing that increase in embodied energy that we saw in that theoretical graph earlier. So operating energy is decreasing, but embodied energy is looking rather stable. There is a slight increase, but it's it's nowhere near the magnitude that the theory was suggesting it might be. And additionally, so these open symbols are the new builds, and the crosses are the retrofits. We can see clearly that the retrofit data is lower than the new build data. So that might be something in the argument towards, do we retrofit or demolish? But I'm not going to get into that discussion right now. I've just taken that same graph and I've cut out the new build data. So here we've just got the retrofit data. And we can see that the retrofit lines are increasing very subtly. But I think, personally, I find it quite reassuring that we're not seeing that massive increase in embodied energy as we make our retrofits more energy efficient. I've popped this little figure in on the right-hand side showing 161 kilowatt hours per metre squared per annum of operating energy for a post-retrofit dwelling. So I don't know whether you can see my mouse.
Yeah.
Yeah, okay. I've been hovering my mouse around on the other screen, which hasn't been very helpful for you guys. So that's around here. So just for some context, you can see that. So yeah, I think from this, I'm going to say that we shouldn't dismiss life cycle analysis and embodied energy, but we do need to keep it in mind, and we definitely need more data on this. So this data was from quite a broad literature review. Of the retrofit case studies that I found, we had 7 studies which covered 12 buildings. They were from Germany, Netherlands, Spain, Belgium, Canada, and Brazil, and 1 building from the United Kingdom. So of a housing stock of 28 million, I think that 1 study on embodied energy and operating energy balance is a little bit limited to go drawing strong conclusions from. So yeah, I think this is reassuring. It shows that we need to be retrofitting to reduce operating energy without too much concern about the embodied energy, but we do need to keep embodied energy in mind, and we certainly need to standardise how we're delivering embodied energy calculations. So thank you very much.
Fantastic.
And I'll hand back to Jonathan.
Thanks, Lois. Yeah, if you just stop sharing and then we can see everyone's faces, which is good. And I think that really puts in context the kind of targets that John was outlining. When you scale it up, we need some more data on embodied energy, don't we? So, okay, we've got some questions from Anika, and I wonder if you could limit it to 3. Before we do that, these questions are for Marianne, Lois, Julie and John. Marianne, I wondered whether you'd just kick us off just by summarising basically the different things we've heard and kind of the learning, how we're going to incorporate that into our idea of zero carbon ready in terms of, my home energy planning and stuff.
That's a lot to ask on a Friday night.
Sorry, it is all in the blog if people want to read it.
Yeah, I suppose if people want to read the blog, it'll be slightly more coherent than I might be able to be right now after a week of work. But I think the point is that when we've talked in the past about focusing on space heating demand and looking at the whole, so when we're looking at targets in My Home Energy Planner, we look at everything, not just regulated energy, because we're really interested in what happens in reality in terms of carbon emissions. It's not just about playing a game with it. And also probably that we have to be quite ambitious with that, and it might not be that everybody right now can afford to do everything or has the time or the headspace to do everything, but that we have to plan to seriously improve our current building stock in line with the kind of stuff that John's talking about. I think what's interesting for me is probably the kind of missing part of this discussion is maybe more on the energy systems side of stuff and demand response and how that all comes into play. And I don't feel like I know anywhere near enough about that and where the balance comes in all of that.
So to be able to shift some of that, renewable energy when the sun's shining to when it's needed. Yeah, and
I think the other thing is the importance of peak demand. So we spend a lot of time talking about how much energy is used over a year, actually in terms of the capacity of the system, it's what the demand is on a cold November tea time that's going to be the thing that's the limiter.
Yeah. Okay. Anika, do you have, what I want to do is 2 or 3 questions for the panelists, just to address them all sort of together. Those that can address one point more than another, that's fine. And then we're going to need to wrap it up because we're getting on for time, unfortunately. So do you have 2 or 3 questions for us, Anika?
Yeah, so there was an early question from Rishi. What about decarbonising hot water?
Yeah, we're talking about space heating demand. So what about hot water? Yeah.
Shall I say all the questions now?
Yeah.
There's lots of comments and questions about the Green Homes Grant and PAS 2035. So one clear question is, should all the work on the Green Grant Scheme be done by PAS 2035 registered contractors? And then there were some comments and questions about Lewis's analysis and sort of new build and retrofit and what the differences are. And I realised all those questions are probably lots to say, and you can't really say much in a short amount of time.
Okay.
Just to say that we will try and answer these in a blog and sort of answer these questions next week as well.
Yeah. We'll invite people to respond. So yeah, the hot water question, I think the PAS 2035 and the Green Homes Grant was also about retrofit coordinators and the capacity for those to deliver. And then, the new build embodied energy. So does anyone want to respond to that? John or Lois or Julie?
Can I suggest, I'm going to be slightly cruel to Julie and say that maybe if Julie takes the hot water one to begin with.
Excellent question. Yeah, it's the bit we always forget. But that's also because, to be fair, once you've dealt with water efficiency measures, I mean, you've pretty much done what you could on reducing demand. And it is it is a very difficult one, and it's one of the drawbacks of heat pumps, because generating hot water means you need it at higher temperature than you could with space heating to avoid Legionella, and heat pumps work less efficiently. They still save carbon compared to a gas option, but they do work less efficiently than when they can generate space heating for your radiators at low temperatures. And the other issue, particularly in big homes where you have a lot of hot water demand, is that you're quite likely to need a tank in order to be able to respond to demand when you really need it, while a boiler is much better at responding quickly. Which is why, again, we go back to the fact that boilers, it's a fact, it's an incredibly simple, cheap, adaptable solution. So it is more of a difficulty to move on. I had to advise a friend recently who was moving to a massive house with 3 young children, telling her to go for a heat pump right now, and her boiler is still working, etc. I'm still hoping that in a few years there will be better solution. It is difficult where you have a large house with hot water. You still save carbon, but it's not an insignificant capital expenditure. Sometimes we get asked about solar thermal panels. Personally, I don't advise them in individual homes, because you might be away at the time when they produce the most in the summer, and then you dump heat. And I know it's supposed to be free energy from the sun, but as an engineer, having to dump hurts my soul.
John, do you want to pick up something about the Green Homes grants and the PAS 2035 as a way to deliver these?
Yeah, can I just touch on the hot water just to finish off? So there is an easy win with hot water, and if you do if you put most new homes into the PHUP and model the domestic hot water distribution, and you model what actually happens in terms of the pipe sizing and the amount of insulation that gets put on, at least 50% of the energy that goes into our domestic hot water is lost through storage and distribution losses in a new build home, and it's probably worse in retrofit. So before we do anything else, we could fix that. We could improve our reduce pipe sizing. We could put more of a proper insulation in, And you can't even buy in this country in some cases insulated jackets for valves. Whereas if you go to Germany and go into any house in Germany, everything, including the valves, is completely tied up and insulated. So that's just something we could do straight away, and that would improve by 25% before anything else. So Green Home grants and past 2030 and 2035. So it's a really difficult balancing act, because we as a community, I think, would really love to see retrofit accelerated as quickly as possible. But there are huge risks. There are risks there's just the practical risks to building fabric if this is done badly. So if we start throwing insulation into the wrong places with the unqualified people without a plan, then it's going to lead to bad outcomes. And then there's also risks in terms of credibility. So are we going to allow all tradespeople to come and do this? I've already heard some anecdotal tales of people knocking on doors saying they're starting selling things for the new insulation scheme. Can I come and see your loft? That kind of stuff. So all those things which we've experienced before, that is exactly what PAS 2030 and PAS 2035 is there to try and do in conjunction with the trust mark scheme. But it's as some of the comments in the chat have said earlier, it's not quite ready. We're not quite there. We haven't got enough retrofit coordinators, and we haven't got enough PAS 2030 qualified companies, and we haven't got the trust mark scheme in place yet. So I'm kind of in two minds as to what I'm not going to turn it down and say don't do it, but I think it needs careful thought, and it needs a bit more coordination than so far we've seen.
Yeah, and obviously risks about the timescale as well. They want to spend that over. Lois, do you want to comment on some of the embodied energy questions around new build versus retrofit?
So yeah, that's a tricky area to answer, because obviously we've got housing stock is in very variable condition, and I haven't studied this in particular detail, but the stuff that I have come across suggests that really the decision in life cycle terms to demolish and rebuild or to retrofit what you've got is based on the evaluation of that individual building. So I think that's where you have to start that conversation. Does that answer the question?
Yeah. I think so. Yeah, definitely. Marianne, do you want to come back on any of those points, and maybe the green grants especially?
Yeah, well, I think I'm very much in the same mind as John, where it's it's fantastic, somebody's listened somewhere and they're going to spend some money on retrofit, but it's slightly terrifying to contemplate what that might end up meaning in reality when we don't have the system set up. And some of the people who we do know are capable of doing this work really well don't currently have those pieces of paper either, and some of those people are on this call and nodding furiously. So it's kind of yeah, and especially as you say with the work, the first tranche of the grant gets launched in September. We don't know what the details are of how quality control is going to work in it yet. We don't know what the qualifying measures are going to be, and it has to be spent by the 31st of March. And I've seen what happens when there's a 31st of March deadline on an external wall insulation scheme with render on it, and it's often not pretty. So it's all that kind of stuff that we need to be thinking about. There was one, and we haven't touched it, but a question came up in the chat there about asking the panelists if they'd retrofitted their own homes. And I'm quite prepared to say I haven't, but I currently live in rented accommodation, so it's somewhat limited what I can do. But I am planning a retrofit in my neighbourhood with a cooperative. And one of the reasons I want to do that, and I suppose this is talking about the new build versus retrofit side of things as well, is that it's an existing neighbourhood in the middle of Liverpool, and the value in the retrofit isn't just to do with the carbon, it's also to do with the fact that you're kind of building on and supporting an existing community rather than demolishing and starting again. And those of you who saw what happened in some bits of East Manchester or some bits of Liverpool, it's kind of the social and economic implications of demolishing and starting again just are slightly terrifying. And I think the carbon terms as well, when you start to think about all the infrastructure involved and the roads that need rebuilt and all of that. So that, yeah. So I intend to, but I haven't done it yet, and you're welcome to nudge me for that.
Right, I think we're going to have to wrap it up there because we're getting on towards 10 o'clock now, and but it's been a really fantastic evening, and thank you everyone who's contributed. What I would say is this discussion and debate around zero carbon ready homes isn't going to end here. Part of what we're trying to do is to take the learning, the fascinating learning that Julie, John, Lois, Marianne and other people have, and to package it in a way that we can communicate to householders and to a general population, and also to government as well. And we are lucky to be in a situation where government are listening to us and the work we're doing and looking out for that. So yeah, do have a look at the blog, but what we'll be doing is taking some of this research and this understanding and this discussion we've had tonight and putting it into our communications, reframing our ends as we've talked about, and the tools we use like My Home Energy Planner. What I would say as well is, if you've been interested and fascinated by tonight, as I have been, we've got more webinars coming up and more opportunities for discussion and debate and for learning. We've got our heat pumps course running at the moment. We've got a session on the green grants and all sorts of things as well, and more experts sharing their knowledge and expertise. Take a look at our website and we'll post something in the email that goes out to everyone after this event. We'll also post out the videos of the two sessions, the AGM and this session, and all the presentations. And we'll do a bit of a review of all those questions that we've had in and try and answer them as well. But Anika has one thing she wants to introduce you to, and I will put a link to it in here. So yeah, you've been spared Slido in this half of the session, but do click on this link and have a look at our Jamboard. And I'm going to share the screen, Anika, so that people can see it as well.
Okay. So if you will bear with us, this is just a helpful thing for us to understand how this evening was for you. The good things, the bad things, any recommendations. So it should be much simpler to use than a Slido, which is in this evaluation. So if you go along to the left-hand bar, you'll see on the left, there's various icons. So if you put up one with a square, for example, that should pull